I'll apologize in advance that this presentation's a bit out of order. So I'm going to start now with the PowerPoint that goes with the stuff I've been doing related to HuggingFace and Gradio. So just to get some context down as to what is it. And as I mentioned in the just ad hoc discussion, you can think of it as a GitHub for AI and ML. You go there by going to HuggingFace, one word, obviously, .co. It is an AI community as it presents itself, and that's a fair representation. It hosts models, data sets, repositories, and spaces. A lot of stuff. What are those things? Community, a collection of people, right, that are doing similar stuff that want to learn and share with each other. The models are essentially, as we know, approximations of complex systems that simulate some outcome in the actual world. In this context, a model is something somebody develops and trains and so on. Most of the models that you'll see in HuggingFace have actually been through a rather rigorous sort of qualification. They'll have a lot of details of how well they perform and so on. Now, that's not to say every model is, because I could create a model and put it there with absolutely no, validity or quality, but you can bet that model wouldn't make it into the most popular models being utilized. There's also data sets, and data sets are collections of highly curated data. And they're sometimes in a particular domain, such as healthcare or finance or whatever. You also have repositories. It does store your data. You have a Git interface so that you can work remotely and commit and also with your team. So it's nice for that. And there are spaces, and spaces are basically environments where it's a combination of compute plus model plus the actual kind of environment for it to run, plus probably some data, depending upon what you're doing. And it does support development and execution and evaluation of models. What's Gradio? Went over it a little bit. It's a great way to create a demo, is what it comes down to, for anything, but especially for things like machine learning and large language models. There is an SDK built straight into HuggingFace, so when you create a new space, you can specify that you would like to start with Gradio installed. This is what I've already shown you before. Very simple hello world application. And literally it says hello and your name, right? And that's what we basically do. You type in a name, you get back a response. And the code you can see to do that is not any more complex than basically a function. So what we're doing here in that constructor, essentially for an interface, is passing in a function. In this case, it is greet. And that's the function that will be called anytime there's something to deliver to that function for evaluation to return back and display on the screen. So whenever I click that submit button, it's going to pull the text out of that text box that's got the label of name and put it into, call the function. The results of that function will be displayed in the output. So great start. Let's talk a little bit about tasks in the HuggingFace world. And HuggingFace, this is one thing they do that is really very cool. You go to huggingface.co/tasks, and you're presented with an organization of models based upon what you kind of want to do. They're at a high-level domain, so computer vision, audio, tabular, multimodal sort of things, which are really cool things. That's like potentially lang chain sort of things, right, where you're chaining together multiple models together inside of the same execution. Reinforcement learning, that's an AI branch that is pretty compelling and pretty popular, or was, until LLMs kind of stole the spotlight. That's how Go was beaten, how the Go expert was beaten, was using reinforcement learning. NLP, which is what we're looking at for the example that I'm thinking of doing here. And you can see on the screen the NLP tasks that are available, have collections of models. Table question answering, not as many. There's only like 82 models there, but generalized question and answering, there's 9,000 models. You think of things that might work well for a chatbot kind of simulation, such as the thing you do for a group project in this course. Most of these would fit fairly nicely. You could have a translation chatbot. That's a fair thing, not revolutionary, but certainly a good demonstration of the concepts. You could have feature extraction. And what feature extraction does is you give it, you load up generally a pre-trained model, then you invoke a method on it that basically return back the features inside of a string that you pass in. What it does to make that happen basically is normal to most processing inside of natural language processing. You tokenize the input into some understandable thing, likely a dense vector, and then pass that into the model. You may do some regularization of the model of that vector first to bring everything into the same scale. You get back some stuff, you turn that back into something that's human readable. And so these are all things that could be. Summarization is an example as well. It's something that I'm using. Sentence similarity is pretty useful as well for being able to ask how close are sentences to each other. And then fill mask is kind of that whenever something has been redacted, can you unredact it kind of concept. So a little questionable perhaps, but anyway, something to think about. Text classification you could as well. That's where you're likely going to get things like sentiment analysis. So summarization, cool technology, right? You give it a relatively large amount of text, you get back a relatively small amount of text. That's how it's supposed to work. Ideally, in a good summarization is going to be one that presents the most pertinent information. The way that we typically do that is similar to everything else. You take that string, run it through a tokenizer. That tokenizer is then presented to the model. The results come back, turn back into a string or to whatever, and then you get the results. The nice thing with HuggingFace is that they abstract away a lot of this stuff in varying degrees of abstraction. So in this case, we're being very, very generic. What we've done, or I've done, is created another space, and I called it summarization. So you can see up at the top here, we've got Lake House summarization. And then underneath of that, I've taken, whenever I created, I selected that I wanted the Gradio is installed as well, already there, ready to go. And so I modified the function to call summarize instead and changed the name of the function to summarize, then added a pipeline instruction. So we create a pipeline telling it that we want to summarize. That's what summarization tells it, is that's the task we want to complete. And then all we do is call it. Basically, the pipeline that's returned to us, we evaluate it passing in the text, and we get back a summarization. So it's that simple to get started. Not going to win any awards as far as how elegant this is or precise, but it is sufficient. And you can see here the results. And to see this running real time, we'll go over, and as soon as I find the right slide, we can see this. And so I'm basically passing in something from my resume. Yes, I know a little bit, perhaps self-centered, but anyway, it's some text that was easy to grab. And then you can get back a result. I could do something similar while that's running. I'll go find some news and grab a story. So you can see with the summary, the text that came back pulled out 1, 2, 3 sentences, which are pretty important out of that whole thing. Not getting into politics too much, but here's something with some text. She probably get that. And she feels she's no longer bound to do something. I don't know, whatever. So I'll Control A, Control V. It's a fair amount of text, right? So she no longer feels bound by the national to pledge she made to endorse the eventual nominee. So she's, long story short, looks like that would be saying I'm going to run as an independent and be a spoiler, right? Is the idea. We'll see how well this does, because sometimes large amounts of text break things, and in particular, there's an input vector, all right, and this one did okay. So let's see here. Yeah, pretty cool. It didn't do a great J of what the Constitution, but it's the Republican the Constitution here. So it pulled out pretty pertinent stuff. So not bad. One thing that we do have to do when we do this sort of stuff, I showed you the easy bit, right? Making the change to this, and it's not that any of this is terribly hard, but that's the function that I just showed you. I do also have it running inside of Visual Studio Code as well. This was working once I opened up the right directory. So the part though that did require getting right, you've got to obviously, if you're using some of these functionalities, things like pipelines out of transformers, you need to make sure that the system knows that you want transformers and TensorFlow and Flax in your requirements.txt file. So you do have to add probably at least this one. I believe this one as well. I'm not sure about Flax. And that basically is necessary to be able to build and run the function and actually do the summarization. But really simple stuff, really cool stuff, and it shows you the power that Gradio brings as far as with a small amount of text, you're exposing and democratizing AI for people that know how to write Python functions, basically. And so that with that, I'll go ahead, shift back to the presentation and go to the obligatory question slide. As always, if there are any questions about this material, reach out to me and let me know. I'd love to hear them. Stay safe. We'll talk again soon.